26 out of 52. One half.
I would leave it as 26 out of 52. Because you're going to have a common denominator here to make
Yeah,
it
that's
easier.
true.
Right, because the rest of them are not going to be denominator of one half. You're going to have to find the least common denominator anyway. What's the probability of a card less than 5?
16 out of 52?
It's a
Are
5
you
and
saying or are you guessing?
No, no,
It
it's
just depends on
20
if
out of
we're
52.
accounting aces one, right?
Yes,
We're
we are.
counting aces
So,
as
Okay, then yeah,
so-
16.
no, 20 out of 52 if we're counting
Aces are counted one, as
Aces
one.
are counted as 1.
So,
4,
ace,
3,
2,
2, 1.
3, 4. Oh, my bad.
Saying less than 5 does not include 5.
Less than 5 does not. Yeah.
Less than 5, right,
So that's
is
1 and
ace,
4.
2, 3, 4. There are 4 different numbers. There are 4 different suits. So 16 out of 52.
Probably heavy metal.
But 8 of those would also be red, so it's minus 8 out of 52.
Correct.
Okay.
Of those 16 cards, 8 of them, or if you want to think of it this way, of these 26 cards, 8 of the 26 cards are also less than 5.
Yeah.
Right? So you end up with 34 out of 52. Which you then convert to a decimal point. And it'll probably somewhere close to 0.58. Yes, there, Tyler, I might be wrong.
0.65. You don't believe me?
Nope, I believe you.
0.65. Okay, so now that I've written it down, I can look. Do it over. Say it again. Just put the numbers
What's the
there.
probability of drawing either a red card or a card less than 5?
Ace counted as 1.
Yes.
So we got 26 out of 52 based on the red card. How many red cards you can draw, right?
Right.
Because 13, 13, 26 out of the 52. Plus, the 16 came from the 5 or less.
Less than
Less than
5.
5.
Yes.
Thank you. Okay, minus 8 because
Probability of red and less than 5. How many cards less than 5 are also red? Half of them are black, half of them are red. So 16 cut in half is 8.
thank you divided by still the same 52 equals, and that's the math. Okay.
15 what?
No, my calculator. You need to stop.
8 out of 52. This whole thing represents one draw, one card from the deck. Right?
That's what I got.
That makes sense?
It does.
Right. So what's the probability of drawing? How about a red jack or a card less than 8?
Red, jack, 4.
Which rule?
Addition.
Yes.
Broadly, yes.
Or
There's
less.
going to be a little quirk here.
There
Oh
is
my
no card.
God.
That's no. Wait. There is cards that's less than 8. Red, jack, or. So you can draw. A
Those
red.
are separate terms in the equation.
Right.
When I say red jack, right, the interpretation of red jack, that's a card which is both red and a jack.
So that's 2, right?
There are 2 ways in the deck to do that. Right? But you also
Diamond
calculate
heart.
that as probability of red times probability of jack.
Oh, okay.
And you'll get the same same result.
Well,
So you're saying you can use
Sometimes
addition or
the
math?
and is
I mean-
implied, and in this case the and is embedded here. In the same way that if I say less than 8, right, less than 8 is also equivalent to, I'll redraw this one, I'm going to expand it. Right?
Okay.
That's the probability of ace
I'm not writing that.
or 1 or 2 or 3 or 4 or 5 or 6 or 7. Right?
I see.
Yeah.
In other words, this is an application of the addition rule embedded into an addition.
Cool.
This is a case of multiplication embedded into the addition rule. Right? When I say red jack, that's both red and jack. Right?
Yeah.
Now, you could actually work it out in the math, but most people intuitively recognize there are only 2 jacks that are red. Jack of hearts,
Yeah.
jack of diamonds. Okay. So the first number, probability of red jack, is 2 out of 52. Right? Probability of less than 8 is 4 8, 12, 16, 20, 24, 28, 32 possibilities, right? Because there are 4 ways to get each number out of 52.
So, 32.
Wait, what? What is that number?
Less than 8.
32 out of 52.
Oh,
There are 4 aces, 4 1s, 4 2s, 4 3s, 4 4s, 4 5s, 4 6s, 4 7s.
So 4 times 8.
Four counting aces as ones. Unless I say otherwise, aces count as ones.
So we got the same numbers
So
last
8
time.
counted as
And
ones.
this- well, hang on a second. Is the red jack mutually exclusive from card less than 8?
Yes.
Yes.
Which means you're dealing with the specific
Yes.
rule, which means this term, well, the term will be the minus term, does not have any representative number,
Yes.
right? Still there technically in the formula, but it equals 0, probably A and B equals
Why
0.
is it mutually
Did you make them the
exclusive?
same exact
Because you can't
probability on
have a
purpose?
red jack
That's
and
kinda
a
cool.
card
You
less
just
than
can't.
8. Like, you can't draw a card that is less than 8 and be a jack and
Because
be red.
jacks are 10
No, jacks are like technically 11.
or face cards.
Or just face cards.
Jack
They
will be a
don't
face
have
card.
Yeah.
We are not going to consider the face cards numerically, but some
Okay.
games use them numerically. The jack is 11, the queen's 12, the king's 13.
But it's
But we are
just a
going to use
face.
aces 1, even though that's a.
Aces are one. Ace is not a face card.
It doesn't
Okay.
have
It's
to
a
be
letter.
on
It's a
the card.
unique card.
Okay. So
Well, here's a fun
why am
little
I
deck trivia, right? How many jokers in a typical deck?
2?
If you keep the jokers in the deck, these numbers change.
Yeah,
Instead of being
yeah.
out of 52, they're out of 54.
Mm.
Here's another really obscure question. See who knows this one, right? How do you differentiate the 2 jokers from each other in a deck?
It depends on the color. If it's colored or not. Because
Yeah.
it's usually a black and white one and a one that's colored. And the modern day ones, not the ones from the 80s.
There is a traditional, it doesn't always apply to every deck, but traditionally, there's a way to differentiate the jokers. And it's not because one's black and one's red, right? They should have the exact same gesture image on them, right? One of the jokers will have the publisher's name and title on it.
Oh wow, cool.
Seriously.
Okay, why
And
would
that's
you
Big
need to know
Joker.
them? Yeah, it's Big Joker. Why would you ever need to know the difference between the 2 jokers?
Someone mentioned it specifically. But usually the copyright information, because it's a published thing, the copyright information is listed on one of the jokers and not the other.
So finish explaining to me, y'all, what y'all were saying about it saying or, but that actually means and, because it made my brain go to scrambled eggs.
Or does not ever mean and.
I think it just,
You just
he was
said
talking about how,
you just said you cannot have a card that's jack and 8. So
Correct, that's mutually exclusive. So the red jack, the
but
8,
it's saying
less than 8,
or.
those 2 things
Because you
cannot
have
happen
to
together.
have the and down at right here whenever you have the.
Because it's red
Formula.
and jack, is that's where
In the
they
formula.
kind of.
Yeah, this one
You don't
technically
need
is
that
red and
part.
jack.
Yeah.
So if I were to write this
So,
completely out, this would be the probability
intuitively-
of red and jack,
like for this one.
parentheses, or 1, or 2, or 3, or 4, dot, 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 up to 8, like that.
Because with the cards, we all kind of know that there's only 2 red
Right.
jacks.
So
But
you
if
can
there
show,
was,
but you can actually calculate it,
yes,
right? You can actually calculate it using the multiplication rule over here.
yes. If it was a different example and we didn't know, then we would have to write it out like that, like red and jack. That's where the and comes from.
Right. The red and jack is implied when I say red jack. That means a card which is both red and a jack in terms of characteristics.
So that would be 2 cards, right?
No, it's a single card
That meets both.
that meets both criteria.
Yeah.
So there's not a heart or a diamond that's both.
Is that a red jack?
Yes, it
Is
is.
that a 1 card? Is that a single card?
Mm-hmm.
There's a red jack.
Mm-hmm.
Right, so it can be occurring. Those 2 events can both occur in the same card. Right?
Mm-hmm.
Sometimes people make these problems harder than they should.
Great. Am I?
All right, so let me.
Yeah, I think you were. I think
in my next
you were
couple minutes,
asking
kind of
about
expand this.
and.
And I'm generally doing it here.
It's
But-
0 here because.
Recognize that once you start with the basic addition, the basic multiplication rules, with 2 events, these can expand to multiple events. For example, if I take, well, let me get rid of this one. Probably more confusing. If I take probability of A or B, and I extend it to probability of A or B or C, right? So I can say something like, what's the probability of, let's say, a black card? Actually, that was the same, because the B will represent black. So what's the probability of, let's say, an ace, or a black card, or, oh, we'll say queen. right? So queen close to, I don't know if there's a C in the deck specifically as a initial. So what's the probability of ace or a black or a queen, right? 3 events, probability A, probability B, probability of C. If I am using the generic addition rule, I'm using OR, generic addition rule, this is going to be a bigger equation than just that. It's going to be the probability of A plus probability of B plus probability of C.
And you could also have black aces or black queens. So
Then you need to look at the dual cases,
Yeah.
right? If I look at the dual cases, right, this is going to be, I'll do it this way, minus the probability of A and B, that shows up in the original case, minus the probability of B and C, minus the probability of A and C. Right? But now I've subtracted more than I need to. I have to add back in the probability of A and B and C.
Dude,
Heck no.
this is ridiculous, actually.
Can
Wait till I get
actually
to
opt
4 or
out of
5
the
of
test?
these.
Can I opt out of the test? It's dropped anyway?
That formula can be specifically generated from the simple formula I've already given you. You can actually expand it, create it. Right, by modifying your parentheses and using the double case as a single case. We are going to do. We are not going to expand the formulas. I'm going to simply give you the formulas. I'm going to point out for all the addition rules, for every characteristic events you're adding, right? When you're looking at a single characteristic, probability of A, probability of B, probability of C, you're adding those to the probabilities. For double characteristics, so you're looking at A and B combined, right? You're going to subtract that off, because you already added it in once for the single. When you get to the tertiary case, you have to add it back in, right? If I went to 4 characteristics, probability of A, or B, or C, or D, right? First of all, I'd have 6 different double cases. I'd have 4 different triple cases, right? I have 1 combined all 4 characteristics. Do I add or subtract the combined 4 characteristics?
What? I don't know.
Oh, I just don't know.
Add.
What'd you say?
You said combine, I would say add.
Right, A or B or C or D, right? Initially, I
Are
have
we
to add
gonna
all
have a
single
question
cases.
like this on the test?
No, I'm not gonna, I want you to understand the pattern here, because this is gonna show up in a different format, different way next
Okay.
week. But you're not gonna have to actually do this math.
Okay.
And this will simplify massively, right? Before I do the 4 case, let me show you how it simplifies. If I use ace or black or queen, can I have an ace and a queen in the same draw on the same card?
No.
No. So anything that's got the A and the C together,
Okay.
Cancel out.
that goes to 0, and that goes to 0,
Okay.
right? Because what I'm looking for is probability of ace plus probability of black plus probability of queen minus the probability of ace and black minus the probability of black and queen. But I can't have the ace and the queen together, so that drops off of 0. They're mutually exclusive. I can't have the tertiary case because the ace and the queen can't be together, which means the ace, the queen, and black can't be together, right? So that drops to 0 because events are mutually exclusive, right? So some events may be mutually exclusive, some may not. So for example, this is going to turn out to be 4 or 52 plus 26 or 52 plus 4 or 52 minus the probability of ace and black is 2 out of 52. Probability of black and queen is 2 out of 52, right? And that's it. Right? No, well, I say minus the 2 and minus the 2. That's minus the 4. These 2 things are going to be combined, right? Statement. Be careful how you use on your calculator. Sometimes people go straight across the calculator, and if you subtract the 2 from the 2, you end up subtracting 0 from those, and that's not right. Right? You have to parenthetically add these 2 together, so you get 4 out of 52, and then subtract that from the total over here. Right? Anyway, these are the single cases by the time. The double cases are, so there's going to be the minus probability of A and B, probability of A and C, probability of A and D, probability of B and C, probability of B and D, probability of C and D. 6 dual cases, some of which may be mutually exclusive. Right? Those are all 6. But then I've got to add back on the dual cases of probability of A and B and C plus probability of A and B and D plus probability of B and C and D
Yeah.
plus probability of A and C and D.
Have fun.
This one's missing the D, that one's missing the C, that one's missing the A, that one's missing the B. That's 3 cases. But then I have to subtract off.
Why? That does not make any sense.
You should have like a default test grade for people.
Here's why it makes sense, right? Go back to this example, right?
Mm-hmm.
Suppose I've got probability of red or a face card,
Mm-hmm.
right? I can have red face cards, right? Which means I have a red face card, I've counted it twice. I've counted it as a red card first, and then I've counted it as a face card twice, which means I need to subtract away once. That's when the subtraction comes away. In the double cases here, I've added in all the single cases. When these things double up, I've already added them in once, I have to take away the single case when they occur in double, right?
Yeah.
But then, at this point, I've taken them away one time too many, so I have to add back in the triple case. By adding the triple cases, I have to take away the quadruple case. Alright? This pattern is consistent. Add, subtract, add, subtract. So if I had the probability of A, or B, or C, or D, or E, or F, there's one case where all 6 things show up. Do I add or subtract it?
Subtract it.
Are you guessing or do you know?
I know this.
You
Because
subtract
that's what you
it.
do at
You would
the
subtract
end.
it.
I said this.
Because you would add in all the 5 cases and subtract
And
one 6
subtract the
case.
6th one.
Right? If you have 6 cases,
Still don't get it, but I knew that answer.
if you have 6 cases, how many double cases are there?
12. 6, 1, 2, 3, 4, 5, 6 double cases. 1, 2, 3, 4, 5, 6. So would it be 3 cases then?
It would be like 10
6,
of them.
A, B, C, D, E, F.
10 double cases. 10 of them?
A to F.
Wait.
So
It'd be
it would be
180.
6 divided. Oh,
Oh. Us both over here trying to do this.
I will tell you how to do that next week.
do we need to know how to do it for the test?
Not for the addition multiplication, but you will have an indication for its use in the stuff we'll do next week. There are multiple ways to do it. One way is calculational, one way is simply kind of memorizing it, one way is in tabular form, whichever way works for you.
Are you teaching us how to do it like the book is? So
Mostly.
When I go and look at
If
the
you
book,
go into the book, you're definitely going to get this. You definitely get mutually exclusive. I don't think your text talks about mutually exhaustive. You'll definitely get random, you'll definitely get independent, you'll definitely get with and without replacement.
so
All
the,
those terms are in the text.
so the textbook can help me with this test for sure.
I would think so.
And this is called what again?
This is
Probability.
probability. These are the basic probability rules. Okay.
Khan Academy.
From
And notice, well, at this point then, for the exam, we've got z-score formulas, we've got probability formulas. Don't leave, I'll give you the homework for tonight.
Oh.
So we've got 2 weeks left this week and next week to do the homework. So this is the homework to give you some practice with the probability rules.
Gosh.
Yeah. How big is your dog? Does he want to be there?
I don't.
Oh yeah.
Is this too big?
She's a teacup Yorkie.
Oh.
Boy. Yeah, I'm not gonna make a smaller one.
Okay.
And so this is.
I'll make a smaller one.
Yes.
Okay. Thank you.
What's her favorite color?
Pink. Maybe that's mine. Make it.
Yeah,
Dogs do not have favorite colors.
Y'all just projected
well,
that
your
color
favorite
onto her.
Dogs can't see in color.
They
They
colorblind.
can't see red, can they?
They might be able to differentiate some long wavelengths, but it's not entirely
I'll
conclusive.
find
They
you
can't
some
see
pictures.
color.
Thank you.
You're
All right, very quickly
And
here
let me
before you
know
head
what
out.
you charge.
Well,
Here's the
I'm
homework.
gonna pay for it.
Homework is basically a series of 6 big problems, each one of which collects small problems under. The first group is incredibly easy. Right? The first group is just simple stuff, right? Using the addition rule. As you go down the page, The hardest problem on the first page is the very last one, which is going to be a combined addition and multiplication rule. Two rules are going to be in the same formula, right? You're going to have a first draw, second draw, and a third draw, right? Kind of watch the language, watch the wording. I definitely want to point out though,
Face.
when you're at the top of the second page, right, if it says what's the probability of cracked green or uncracked red or something like that, that is implied and. Right? Cracked red means a bead or Easter candy, which is both cracked and red. The and is implied. Right? And the next thing at the bottom of the last two questions, number 5 and number 6. Number 5 and number 6 are Z-score problems, not probability rules. 5 and 6 we use means and standard deviations to calculate average lifespan for single counts. That's basic Z-scores for 5, and then sampling distribution for number 6.
Say that again. Number 5 is what?
Z-scores.
It says the distribution on here.
Yeah. Use Z distribution. See, well, my point is you're using these formulas.
For
Right.
number 5 and 6.
For number 5 and 6.
Okay.
These for 5, that one for 6.
Okay.
Right? Because for number 6, you're drawing multiple individual cases as a sample. So you have a sample mean and a population mean.
And that's for all of the questions in number 6? Or
Yes, the embedded, all 3 questions under number 6 use the same distribution.
I don't think I got that.
This is due next week. We'll go over it we'll go over it next week after you turn it in. I'll have another homework next week, deal with next week's stuff.
But we won't get to go over that one before the test.
We will go over it just immediately before the test. So you'll be turning it in and I'll go over it prior to doing the test. We only got a limited number of days.
So this is easier than what we're going to be learning the second half.
It's easier, it's equivalent. I think it's comparable. I think next week's a fun set of equations.
Fun. You is,
The mean of the population.
And X bar is what?
That's what I was gonna ask.
X bar is what?
Mean for a sample.
Oh, so they both mean mean. Okay,
Yeah.
I thought, because there's one